Hello. All right, so this right here is a library of C++, All-in-One for Dummies, 3rd edition. There's 6 books in one. So we are in book 4, chapter 2. Yay. And this particular book is all about book 3, chapter 4. Double checking that. Book 3, chapter 2. I stated correctly and then I read it wrong. Fixing problems, and specifically, this chapter is all about debugging. Okay, so I'm gonna set my timer on my watch. The goal is 30 minutes. Of reading time. And then closing out the stream shortly after that if I don't feel some boost of energy. Chapter 2, Debugging an Application. In this chapter, working with debuggers using the code blocks debugger, tracing code flow through an application and in and out of functions, using other debuggers, getting seriously advanced debuggers, adding command line arguments to code blocks debugging. Okay, so I don't have all the time ever, and this is a review for me, so I'm opting out of trying to use their code blocks. But if you're at all interested, you can get the book and download what they're talking about and play around with it. It'll be great. Personally, the goal is to get through the rest of this lovely book. This is the full book. I'm about halfway. So then I can hopefully start doing some coding on my end with what I want to do, not just their models. Okay. Because I've been taking a nice long break from C++. Last time I coded anything was back in May, the day after my, what do you call that? Commencement for Masters of Science in Computer Science that I earned this year. Okay. In this chapter, we walk about, never mind, back that up. In this chapter, we talk about how you can use a debugger to track down problems and bugs in your application. Sooner or later, things don't work the way you plan them. In this case, you have several plans of attack. One plan involves a hammer and the computer, but we don't recommend that one. Instead, we suggest using a debugger to try to fix the application. Okay. Just a little more housekeeping. So when it comes to this book right here, this is the 3rd edition. There's 6 in 1. It says, if you're to go on the lovely Google, you can type in C++ All-in-One for Dummies. And if you go, of course, you'll see Amazon. There's probably a Barnes & Noble link too. But if you go to the link there for the All-in-One for Dummies, it'll take you the most recent edition of this book, which upon last time I checked was the 4th edition. So there's like a lot of things that they're mentioning here that may not even be valid anymore on account of things have passed since this book came out. So that's one thing to keep in mind. 2, I have a great affinity for the For Dummies series. Sometimes I'm kind of dumb, but not usually about this kind of thing. But I just love that they're not spending all of it. As someone who went to UCSD for my bachelor's and had to deal with a bunch of academic high-level writing, I don't like it so much. I like when people can just convey information and break it down, make it interesting and easy to understand. I like that. So I like this series, yes. Okay, programming with debuggers. A debugger is a special tool that you use for tracing line by line through your application. Tracing is the act of viewing the code execution flow in an application. Take a look at the buggy program example shown in listing 2-1. This is just a basic application with a main and a couple of functions that we use to demonstrate the debugger. So this kind of time, when it's something hardcore that I have to share, I switched cameras so you can see the page. Water, please. And yes, it is just water. I'm doing my nightly routine that involves drinking water time, preferably before bedtime, so I don't have to worry about. So far, I haven't had an issue with that, but I'm getting older, so I don't want to tempt fate. Here we go. Listing 2-1, tracing a simple application. Hashtag include IOStream. Hashtag include CST D lib. So let's see, C sharp, no, C, I don't know. I know lib is library, D is might be data, I don't know what CST is. Using namespace standard, FCR standard, int count rabbits, int original, int result, oh yeah, that's gonna blow up. You can't do that, that's blowing up. Int result equals original times 2. Result equals result plus 10. Result equals result times 4. See out calculating result in line. Return result times 10. Okay. Listing 2-1 continued. Ooh. Int count antelopes. Int original. Int result equals original plus 10. Ooh. Hello, focusing. Result equals result minus 2. See out calculating result in line. Return result. Int main. Int rabbits equals 5. Int antelopes equals 5. Rabbits equals count rabbits. Rabbits. See out rabbits now add rabbits in line. Antelopes equals count antelopes. Antelopes. See out antelopes now add antelopes in line. System pause. Add this for Windows. Return 0. When you type and run this application, you see the following output. Calculating 80 rabbits now at 800. Calculating 13. Antelopes now at 13. Okay, I was thinking the way that rabbits multiply, you probably don't have enough memory in your system to, after a while, deal with that. And that's a really good way to crash your application. Alrighty, let's see what they say. Okay, it says, now look closely at main and follow it through line by line. The first thing main does is declare a couple of integers. Then main calls the count rabbits function. The count rabbits function declares an integer and completes a few lines of calculations. Then the count rabbits function prints a message. Finally, it returns. Once back in main, the application prints another message and then calls the count antelopes application function. This function also declares an integer, complete some calculations, prints a message, and then returns. Back in main, the application prints another message, and finally the application finishes. Okay. What we just gave you is a linear description of the entire process of this application. You can see these same steps by using a debugger. With a debugger, you can see the computer moving line by line through your code. A debugger performs the first line of your application and then waits for you to tell it to perform the next line, then the next, and so on until the end of the application. tip. In this example, we use a debugger that comes with code blocks application, the code blocks application. If you prefer to use another debugger, recommend that. For most of this chapter, you at least try the code blocks debugger. It's a nice tool, and we think that you'll be happy with it. But besides that, it allows you to follow through the examples we give. Then you can return to whatever other tool you're using. And again, no, I don't have time for all of that. It took me this, I had this book since May, and this is all I managed to get done since then. And frankly, before I started doing this as a YouTube thing, this is pretty much where I was. So no. All right, adding debug and symbol information. When we compile the debug information, you're adding debug and symbol information to the final executable file. This information includes data about the source code files, including the line numbers and the variable names. This is a primary difference between a debug version and a release version of your product. Oh, really? I see. Okay. People typically don't include debug and symbol information in a version of the product that they release to the general public. One reason is that including it makes it too easy for competitors and hackers to reverse engineer the product. Another reason is that including the debug and symbol information makes the application run slower and consume more system resources. However, the actual source code is not in the debug and the symbol information. That stays in the source code file. The debug information instead just contains line numbers, which serve as references, pointers, if you will, into the source code file. So hackers and competitors won't have the complete source to your application, but they will have variable names and other information that can make their job easier and yours harder. Okay, remember, you must know one important aspect before using a debugger. For the debugger to understand your code, you must compile it with debugging information. And the compiler, my apologies, I'm just tripping all over myself today. And no, this is just water. But what I do have is asthma, and what I do take is this medicine, singular knockoff that really does give me drowsies. So that's why I have to take it at night. So I took that about 20 minutes ago, and sometimes it takes a while to kick in, and sometimes it doesn't. Okay, so you must know one important aspect before using a debugger. For the debugger to understand your code, you must compile it with debugging information. The compiler adds extra information to the final executable so that the debugger can locate your source code and variable information. Here's how you turn on debug information. See, this is interesting because so far with my work with C++, I haven't yet used the debugger. I think I wasn't quite having that set up correctly. So, and the other thing was I was kind of like going through doing the tests. So I wasn't really needing to do the debuggers because I was running the tests and whether it passes or fails, and also whether, let's just say, when you first start off with coding, those compiler errors throw you for some serious loops, and you need so much help trying to figure out what caused what. But then as you get used to it, so back when I was doing this time last year, back when I was taking advanced object oriented programming, and I was in the, I didn't have to go and try to teach myself C++, which I effectively did, but I did. That was a choice I made. I'm kind of glad I did because I definitely got good at it. Nice to know that I could get to a point of getting good at it, because earlier in my aspirations of this whole computer science thing, back when I was just working in progress, oh boy, that just seemed like the hardest thing to figure out was how do you get through all these dang errors. So code, debugging, all that jazz, definitely helpful. I have to say my favorite debugging is definitely with just basic C, just using the VirtualBox, just using Linux build, and then just that GDB. Perfect, wonderful, beautiful. Chef's kiss on that one. But maybe I will figure out C++ debugging, preferably more GDB. Actually, no, I think that's what I was using. Yeah, yeah. I rather, yeah. What they have is, I don't know. I like GDB. All right, and it is GDB because it's debugger. G, I forgot what that's for, but the DB is for standard debugger. Okay, let's go. So this is probably going to be just out in one year and out the other, but it's still good information to have a refresher on. Okay, so for the compiler adds extra information to the file exhibit so that they're locate your source code and etc. Here's how you turn in the debug information. That I'm not going to worry about. Tip, after you change the compiler options to generate debug information, you must rebuild your project. The reason is that the compiler and linker must regenerate object files and executable files with the debug information. One thing I need to learn when I get back to doing coding time is how in the world do I get C++ to work outside of Visual Studio Community Edition? That's all I could manage to get it to work on. Okay. So also I was able to get it working on Visual Code, kind of, sort of. But that ended up being such a pain in the butt for the class I had, Big Data. Oh, and it was a group project, and I couldn't figure out why it wasn't seeming to work the code that we had on my computer. I couldn't get it to work on anyone else's computer to see if maybe my computer was just out of memory and giving me the business or not. Oh boy, that this year, yeah, that makes sense. That would that the year of 2024 with everything that's gone on now that I'm sitting here in November, that makes sense that that's how my time at grad school would finish. Yeah, why not? Running the debugger. After you've rebuilt your project, you can run the debugger. To start it, to start the debugger, click debug continue. Okay, again, this is all stuff that I am not going to worry about. So I'm skipping forward to page 390. Okay, this is kind of relevant. This is kind of the typical look at if you're using an IDE, the ASCII debugger. It's reasonable to expect them to have a similar thing going on. So in what I'm saying is it's IDE, and you have your continue. Let's see, and then there's steps. Your step into and your step out, and then you have your breaks, and then there's you would set your breaks in here, and then there's different things that you can do to try to change it. And then this whole idea of there being a window here where you can look, that's your debugger window. Yeah, that's something that is a typical thing that happens in IDEs. So I will just mention that part, but I'm not going to go super into this particular debugger because I don't really. The point is not to dwell. The point is to get through this book and then get to my own coding again. Okay, figure 2-1, the main code box window shows your source code. Sorry. Figure 2-1 shows two special features you need to know in order to successfully debug applications. The first is the red octagon, like stop sign, and the second is the yellow triangle. The red octagon is a breakpoint, okay, yes, at a place where you want the debugger to stop. You add breakpoints to the editing window by clicking on the left side of the instruction where you want to stop. Yeah, that's pretty much the same as it goes with the usual eyes, whether it's JetBrains or Visual Studio Code or Community Edition. When you what? I'm trying to think if there's anything else that I've used. I think those are pretty much the three. I haven't yet had a benefit of having to debug um what's that? I'm thinking of the Python. I'm thinking of the notebook. I haven't yet debugged one of those, so I don't know the setup for that. But I usually end up putting the Python in with the visual community, so I assume I would do it the typical way. Anyway, so then it talks about when you click the spot again, okay, left side. Oh, here's the thing. It took me a while to learn. Some eyes, what you can do is you click it, like right click it, and then you can set it up to do different things. So one of the things I like is to set up on the condition. I found that very helpful for when I was stuck trying to figure out why things went wonky with my big data class with some of the programs. Is you're like, okay, let me set it up to hit this mark, that this integer has to be equal to or greater than this number here, kind of thing. And so, boy, I definitely learned some things during that, even if it didn't quite go well. I definitely learned some things. That's the important thing. When you click that spot again, the red octagon goes away, showing that you have cleared the breakpoint. You can place as many breakpoints as you want in the application, but you can place breakpoints only in instructions. The yellow triangle is the instruction pointer, which shows the instruction that the debugger will execute next. As you tell the debugger to execute instructions, the yellow triangle moves. Whether you start the application in debug mode, whenever you start the application in debug mode, the yellow pointer automatically stops at each breakpoint. Figure 2-1 shows how the debugger looks when the yellow triangle stops at a breakpoint. When you start the debugger again by clicking debug continue, execution begins as if the application is in normal run mode until the debugger encounters another breakpoint. If the debugger doesn't encounter a breakpoint, the dialog box closes and the application returns to the source screen. Remember, if you don't set any breakpoints and try to debug your application, it will run without letting you trace through the code. That is, the application will run as if you're not running it in the debugger. If you don't set, right, look at the debugger tab of the logs and others window shown in figure 2-1. This tab contains debugging messages from your application. Whenever you see the app message, you know that the debugger has stopped at a particular location. Baby shark, baby shark. The remainder of the message tells you where the debugger has stopped. In figure 2-1, the debugger has stopped at line 26 of this file. Here's the file name. CPP_AIO Book 3 Chapter 2 Buggy Program main.cpp file. So go ahead and run the application. Begin by setting a breakpoint at line 23. The int main entry, click debug continue, choose debug start, or press F8 to start the debugger. Oh yeah. Shortcuts, those are great. When you have, especially some of those more long, drawn out periods of debugging, just enjoy your shortcuts. Oh boy, they come in handy. You'll see a number of, here's my rant real quick. It is a darn shame that the school district that I work for implements those little tiny Chromebooks for the students, because they're effectively getting computer light. They're not getting the full computer, so they're not able to use the full benefits of a full keyboard. The fact, like, it took me so long in my life, but of course I didn't grow up with the computer is the thing. Like, when I was a little elementary school student, the only time I had time with the computer was in school, in their computer lab, and it was the black screen with the font that was green, and we played some Oregon Trail and things like that. So as far as like using it for like productive, well, that was kind of productive, but like as far as having to use it to do my homework, no, it was always writing down nicely, and you had your black ink pen and your red ink pen just for corrections and this and that, and your pencils for everything else, sort of deal. And it's a shame that they don't know what end key is. They don't know what a home key is. Those don't exist in those little things. So for me to have like got to my 30s before I learned what those things were and how helpful they are, okay, makes sense. But for them, that's a shame. There's no Generation Z or Alpha who shouldn't properly know what your home key and your end key is. It saves so much time. Or like I have to go through, I can't just assume that students who I work with understand what Control V and Control Z are. And it's like, that's a shame. It saves so much time. Like, goodness, these hacks are kind of important. Anyway, okay. So glad that, so go ahead. On the application, begin and setting point, blah, blah, blah. F8, you'll see a number of messages appear on the debugger tab, and then you'll see the out message when the debugger stops at line 23. If you space your application slightly differently from the way we did in listing 2-1, you may see a slightly different line number. The L triangle should appear on line 23, which contains a curly bracket, meaning that the application is stopped at that line. The instruction pointer stopped at the curly bracket because it is the first instruction after the main entry. Click next line, which is the third button on the debugger toolbar. The button you want is the one with an icon with two squares and an arrow pointing from the first square to the second square. You can also press F7. The yellow triangle instruction pointer moves to the first assignment statement on line 25, which is int rabbits equals 5. Click next line. When you click the button, the instruction pointer advances to the next line. The computer just performed the first line in main, and the next computer will perform the second line in main, which is this, int antelope equals 5. Click next line again. Now the instruction pointer is on the third line of main, which looks like this. Rabbit equals count rabbits, rabbits. This third line of main is a function call, and now you have a choice. Don't click next line. You can either tell the computer to perform only what's inside this function without stopping on each line for you to see, or you could step into it and see the individual lines. Click the fourth button from the left, the one called Step Into, which shows two squares and an arrow going from the left between them, or press Shift and F7 at the same time. When you do, the instruction pointer moves into the count rabbits function. The highlight will be on the first line in the function, int result equals original times 2. When the highlight moved into the function, the computer stepped into the function. Now think about the symbol for the icon that caused this to happen. The icon is squares and an arrow pointing between them. The two squares represent lines of code in the current function, and you go between them or step into the called function. That's the idea behind the odd symbols. The one you've been clicking before, the next line icon that has an arrow going over means stepping over the function. Now, before stepping into this function, because you were clicking lines that were not functions but just individual lines, you use the next line, that is the step over button. But you could have used either the next line button or the step into button, because stepping into a function doesn't bear much meaning on statements that are not functions. Tip: Normally, we use the next line button by default and choose the step into button only when we specifically want to go into a function. The reason is that some lines of code that may not appear to be functions really are. For example, C out A is in fact, I'm saying C out and then it's the lesson less than double quotes a double quotes is and then semicolon is in fact a function, and you might not want to step into that code because either the source code for it might not be present or you simply might not be interested in the details of the function. It's time to see how these debugging features work. The following procedure takes you through the debugging process so that you can see the code blocks debugger in action. If you're curious of looking at this in action, you will likely be able to find something on YouTube specific to this. So if you're interested, you're looking for code, CODE, colon, blocks, boyfriend's calling. Gotta go, bye.